In this lesson, we're going to be looking at a few problems that have to do with proportional sequences. First, what are proportional sequences? Proportional sequences are sequences that have not a common difference, but a common multiplier that multiplies each one. For example, 1 to 2 is times 2. 2 to 4 is times 2. Another times 2 between 4 and 8. 8 and 16 times 2. This is what makes it a proportional arithmetic sequence. There is another one, too. There's all sorts of different ones, and as long as this multiplier is the same, it can be called a proportional arithmetic sequence. Let's look at the problem. In a proportional arithmetic sequence, the third term is 7 and the fourth term is 49. So what's the 100th term of the sequence? So 7 to 49, that's times 7, which means that the multiplier, in this case, and sometimes it can be dividers, the multiplier in this case is equal to 7. Meaning that the second term and the first term that we also know. Second term is just 7 divided by 7, that's 1. And this is the 1 divided by 7, 1/7. Now, what is the 100th term of the sequence? Well, exponents are a big part of proportional sequences because in a lot of these, this is really just different indexes of 7. This is 7 to the negative 1 power, 7 to the first power, 7 to the 0th power, first power, 7 to the second power. And what about 7 to the nth? What about 7 at this, what about the term at the nth term? Well, every single one of these, it's 7 raised to a number of the term number minus 2. So in this case, this would be n minus 2. So that's the answer. 7 is to the n minus 2. Alright, so the 100th sequence, we just substitute n with 2, and that is 7 to the 98th power. So our answer is 7 to the 98th power.